Assalamualaikum and greetings. In this video, I'm going to explain to you guys regarding the preparation of aldehyde and ketone. In general, both aldehyde and ketone can be prepared from two compounds, which is from alcohol. The other one is from acyl halides. Alcohol is being represented by the functional group of hydroxyl group ROH, which we have learned during the first chapter, while acyl halide is one of the carboxylic acid derivative, which is RC double bond O OH. So we are replacing the OH with X in order to have the acyl halide compound. So we'll be focusing on acyl chloride in our discussion. So basically, if you have an alcohol, if we oxidize the primary alcohol, it will become an aldehyde, which is going to further oxidize into carboxylic acid. This depends on the type of the oxidizing agent that we use. If we are using a weak oxidizing agent, it's going to stop until aldehyde. However, if we are using a strong oxidizing agent, it's going to straight away become carboxylic acid. So this is for primary alcohol, and ketone can be prepared from the oxidation of secondary alcohol. So secondary alcohol, just like what we have discussed before, is going to be oxidized into ketone. Doesn't matter if we are using weak or strong oxidizing agent, it will stop until ketone without conversion into the carboxylic acid. For the second method, we are using acyl chloride. If we perform the reduction process by using a reagent called Lidbach, Lidbach stands for lithium triterbutoxy aluminum hydride. It's going to become an aldehyde. And if we are using a Friedel-Crafts acylation, it will become a ketone. Okay, let's take a look at this explanation in details. Let's talk about the oxidation reaction first. If you still remember this diagram, we have alcohol, we have the carbonyl group, and then finally we have the carboxylic acid. So in general, if we have a primary alcohol, for instance, if we have propanol, for instance, if we oxidize it by using a weak oxidizing agent such as PCC, it will stop until an aldehyde. As you can see, the transformation of OH into C double bond O happens at the first carbon of the carbon chain. We cannot use strong oxidizing agents such as potassium permanganate, because later on it will not only convert it to aldehyde, it will further convert it into carboxylic acid. Again, as you notice, the formation of the COH happens at the first carbon of the compound, because the functional group of the OH located at the first carbon. Same goes if we have a secondary alcohol, for instance cyclohexanol. Please take note that for secondary alcohol, doesn't matter if we are using a strong oxidizing agent or weak oxidizing agent, because if we are using strong oxidizing such as potassium permanganate in acidified medium, the transformation of the carbonyl group will also happen at the first carbon, which is attached to the hydroxyl group, the functional group. So what we're going to get is the OH will be transformed into C double bond O. In this case, from the cyclohexanol, we're going to become cyclohexanol. In this form, as you can see here, the first carbon, there is no more hydrogen to be transformed into carboxylic acid. That's why doesn't matter if we are using weak or strong oxidizing agent, it will remain into ketone only. There will be no further transformation into carboxylic acid. For the preparation of aldehyde and ketone by using acyl chloride. Again, acyl chloride is part of the carboxylic acid derivative. If we perform reduction reaction, it will become aldehyde. If we perform the Friedel-Crafts acylation, it will become a ketone. Let's start off with the preparation of aldehyde by using acyl chloride. If we want to take a real example, we change the R into other groups. For instance, let's replace R with the 3 carbon group attached to the C double bond O with the Cl. If we apply the reagent of Lidbach, okay guys, Lidbach stands for lithium tri-third-butoxy aluminum hydride. So the Cl will be then converted into H. In this example, we have butanoyl chloride, and then whenever we apply Lidbach, it's going to perform a reduction reaction which resulted into the production of butanol. The reason why we call this a reduction reaction because the hydrogen is replacing the Cl. Whenever the hydrogen increase, it means that the reduction process happens. Moving on to the preparation of ketone by using the same reagent, which is acyl chloride. So we're going to take the same example, which is butanoyl chloride. So there will be 4 carbon. The first carbon attached to the C double bond O and then Cl. The reagent for Friedel-Crafts acylation is benzene, and then the catalyst needed is aluminum chloride. So what's going to happen is the hydrogen will be replaced by the chlorine from the butanoyl chloride. So in the end, what we're going to get is we're going to get a 4 carbon compound from the carboxylic acid derivative attached to the benzene, which replace the hydrogen, and then the hydrogen is going to attach to the chlorine. So as you can see here, this is the Friedel-Crafts acylation, and this is the ketone, because as you can see here, we have C double bond O attached to 2 carbon. That's all what you need to know about the preparation of aldehyde and ketone. So in summary, both aldehyde and ketone can be prepared from 2 compounds. The first one is from alcohol. Again, if we have a primary alcohol, we need to oxidize it with a weak oxidizing agent so that it's going to stop until aldehyde. We cannot use a strong oxidizing agent because it will become the carboxylic acid compound and we cannot get our desired compound. For a secondary, doesn't matter, we're going to use weak or strong oxidizing agent because later on it's going to end up into ketone only because there is no more available hydrogen to be oxidized into carboxylic acid. For the second method of preparation, we're going to use acyl chloride or acyl halide. By performing a reduction reaction by using Lidbach, okay, we're going to convert the acyl chloride into an aldehyde. While if we have the same compound, which is acyl chloride, and then we perform the Friedel-Crafts acylation with the benzene and also aluminum chloride, in the end we're going to get a ketone compound, which replacing one of the hydrogen from the benzene with the Cl. If you have any question related to this topic, please leave your comment below and see you guys in next video. Goodbye.